Now, if you're perfectly comfortable with using the Euclidean algorithm as shown in the previous video in this series, please by all means go ahead and use it. The textbook shows a 2-column method to keep track of things, and the reason they do that is they have a method for something else we're going to do later, which relates to the activity we did in class on Monday. So let's talk a little bit about this 2-column format, just so you have other options for methods to do these types of problems. We're going to take the example from earlier, which was 426 and 246, the one that we went over that was already typed. And we're just going to, as another example, do the Euclidean algorithm on this. Then we'll compare it with this 2-column format that the book shares. So 246 goes into 426 once, and the remainder is going to be 180. As I said, I like to underline my A, my B, and my R at each step. So 180 goes into 246 once, and there's a remainder of 66. 66 goes into 180, not 3 times, but 2 times. And the remainder, let's see, 66 times 2 will be 132. 180 minus 132 would be 48. All right. 66 equals 1 times 48 plus, what's the remainder? 66 minus 48 would be 18. 48 divided by 18, we have that 18 goes into 48, not 3 times, but only twice. 2 times 18 is 36. When we subtract 36 from 48, we get 12. 18 is 1 times 12 plus 6, and then 12 is 2 times 6 plus 0, which tells us 6 is the GCD of 426 and 246. We saw that in the previous example. It doesn't hurt to see it unfold gradually in front of you. Now let's compare what we just did here with this 2-column format that the textbook uses. So let's shrink this a little bit and focus more on this. Okay, so let's try to understand how this 2-column format in the textbook relates to what was done over here, the traditional version of the Euclidean algorithm. Okay, so we recognize there's the 426 and the 246, and then the 246 gets moved down here. So kind of like how you move the 246 down here. And then what they do is they subtract to get 180, and that's this number, which would have to be brought down here anyway. So after doing this subtraction, they put the 180 over here in that corresponding spot. So 240 divided by 180, 180 only goes in once. So they're putting that quotient there, and then they're doing the subtraction. Okay. So then that's all fine for now. You do the subtraction, you get 66, and then they're not going to do 180 minus 66, they're going to do 180 minus 132. The quotient in this step is 2. So then you subtract 180 minus 32, you get 48. So 48 would have been this 48 here corresponds with that 48, and so that's why they're filling in this 48 here. The quotient between 66 and 48 is 1, so that's why there's a 1 here. Subtract, get 18. And then the 48 minus 36 is 12. It's kind of confusing when you look at it all at once. So what I want to do is I want to just show you how you would develop it gradually, how you would do the two-column format gradually. Quick thing to note before I get to that is there's a version of this where they leave all the quotients on the left. I personally found it confusing to put the quotients like back and forth and like this. I think to me it makes more sense to collect the quotients all in one column, so that's the way I'm going to demonstrate it right now. Okay. We'll leave this here for comparison. So let's make our two columns. We start with 426 and 246. When we do this division, we have a quotient of 1, so this is the quotient column. We do 1 times 246, put it here. So that's 246. We subtract, and we get 180. Now notice that we have the 426, the 246, the 246, the 180 down here. So 246 and 180 are the numbers we're dividing, which means I should write 180 here. And again, I ask myself, 246 divided by 180, what's the quotient? The quotient is 1. So we write that here. We subtract 246 minus 180, we get 66. We then ask ourselves, okay, 180 divided by 66, that's going to give us the next remainder we need. The quotient in this case is 2, right? So we have to do 2 times 66, put it here so we can do the subtraction and get 132. The remainder is 48. Okay, so then now we have 66 over here, we have 48 over here. When we write a number below another number in this scenario, that's where the subtraction happens. So we always need to think of what the quotient is before we write a number here. So at this point we have a 66 over here, we have a 48 over here. So these are remainders left over from different steps. And so we're going to apply the division algorithm to these two numbers, which corresponds to this step over here. The quotient in this case is 1, so I'm going to write it as the next quotient. I'm going to multiply 1 by 48, write it here, and then subtract. So now, what do I have? I have 48 and 18. I have two remainders from two different steps that are one right above the other. And so I need to figure out what is the quotient between these two. Well, the quotient is 2. So I'm going to write the 2 here. I'm going to multiply the 2 by the 18 and write that here, preparing to subtract. So when I subtract, I get 12. Now I have 18 and 12, which are the lingering remainders from two steps, one above the other. When I apply division algorithm to 18 and 12, the quotient is 1. So I do 1 times 12, write it here, subtract, get a 6. And then these are the two lingering remainders. So I apply the division algorithm. My quotient is 2. I do 2 times 6, write it here. I get 12. Subtract, I get 0. Now, since every subtraction result is one of my remainders, I know that the GCD is the last non-zero remainder. Because I got the 6 right before I got the 0, I know that 6 is the GCD. So I had these two methods side by side just for comparison. What you need to do at this point is try not using the Euclidean algorithm the way I have it over here. Try to use just the two-column method to do these hands-on exercises. And then join me in the next video.